this is the third part of my videos on logic, and in this video we're talking about truth tables for negation, conjunctions, and disjunctions. So I'm going to start out with the negation. That's the easiest here. So let's say that I have a simple statement P, and I just for the topic of negation, so we use the symbol the total to say not P. So the truth table is used to give all the possible values of a statement, and so if I have a simple statement P, the definition of a statement says that it can be either true or false, so it's not going to be both simultaneously. So in the truth table here, I have one simple statement, and there will just be these two rows. So for statement P, we do a false. And I'll use other rows to evaluate variations of this statement, but in this case I'm saying not P. So remember, negation takes something that's true and makes it false, or something that's false and makes it true. So I know this seems really simple. This is the truth table for the negation of a simple statement P. Okay, next let's consider the truth table for the conjunction P and Q. So in this case I have two simple statements. I need to consider all the possible combinations of truth and falsehood for the statements P and Q. Now, if I have two simple statements, I'm going to need the second rows in order to consider all the possible combinations. In other words, I'm going to need 4 rows. Now, if you had 3 statements, 3 simple statements, you need P, Q, and R, you would need 2 of the other, or 8 rows, to gather all possible combinations. But here I just have P and Q, so 4 rows is going to be sufficient. Now, I'll start out here all the P and all the Q. In this last column is what alternate true, false.
And then moving over a column to the left, I'll double up and say true, true, false, false. And notice that these 4 combinations represent both being true, P being true and Q being false, P being false but Q being true, or both being false. And those are all the possibilities here. Now, for the conjunction, this is an AND statement. Consider the example, I made a B on the final. And Q is a statement, I passed the class. And let's say that both of these are true, that someone did make a B on the final and they passed the class. What would that mean about the statement, I made a B on the final and I passed the class? Well, if both of these are true, then this AND statement is also true. So this P is true, Q is true, so that says that P and Q is true. Now, if you made a B on the final, but you did not pass the class, could you say truthfully, I made a B on the final and I passed the class? No, you couldn't. This would be false, and likewise, if you did not make a B on the final, then you would not be able to say I made a B on the final and passed the class. That would be false. And certainly if both components are false, then this compound statement, the conjunction, is false. So notice that the conjunction is true only when both the simple statements are true. What about for a disjunction? So we'll consider the different combinations of P and Q and look at the disjunction. So this would be an OR statement. Now, I made a B on the final, or I passed the class. Now, if it's true that you made a B on the final and that you passed the class, would it be truthful to say I made a B on the final or I passed the class? So the tricky thing here is to remember that when we're using the word or, it is not an exclusive or. And so it could mean, so our or means one or the other, or both. And notice, so since both are true, the or statement is true. And again, here we have one or the other. That's certainly true. One or the other. The first one's false, but the second one's true. But in the last case, where both the simple statements are false, and if I say one or the other, that would be false. So this is false only when both are false. So notice in a conjunction, it's true only when both are true. For a disjunction, it's false only when both are false. All right. Now, let's look at some other combinations here for some more complex statements. So, and a strategy for constructing the truth tables. So I have the statement not P and not Q. So I have two simple statements, P and Q. So I know I'm going to need a row for P and a row for Q. And I'll go ahead and fill in true, true, false, false, and true, false, true, false. So those are all the combinations for P and Q. And then I'm going to add columns. So I have a component here of not P. So I'm going to go ahead and add a column for that. It just reverses all the values of P. So this would be false, false, true, and true. I also need not Q. And so that will reverse the values of Q. So this would be false, true, false, and true. And then finally, I can take the conjunction of not P with not Q. So I'm really now only considering these. This is an and statement, which is only true when both are true. So this is false, 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 and true. So that's the truth table for this compound statement. Let's do another one. I want to add in another tilde in here. So this is P or not Q, but we're taking the negation of this entire statement. So it is not true that P or not Q. So again, I have two simple statements, P and Q, true, true, false, false. Those are the values of P, and true, false, true, false. So those are all the possible combinations for just the two simple statements. I know I need the negation of Q. So I'll take my true value to make it false, false, make it true, true, make it false, false, make it true. And in this case, I need to consider P or not Q. And so I'm really trying to just ignore this and considering, so I'm just going to cover it up. And I want to say this is an or statement. So it's true if one or the other is true. So I had a true and a false, that's true. And it's true when both are true. It's only false when both are false. So that's in the third row there. And then this is true. And finally, I have the negation of this whole statement. So the negation of P or not Q. And then I'll just take each of these values and flip it. So this would be false, false, true, false. Something that comes up, there are some things that are similar to algebra and some things that are different. So for instance, one thing that I think is similar to algebra is that we work from the inside out. So I need to evaluate what's inside the parentheses before I consider this negation. But something that people have asked, and I think is a very good question, is, do we have like the distributive property? So could we just take this negative and distribute it? And that does not work. So in future videos, I'll show you why this is not true, and that we can't just distribute that negation across that statement. All right, that's it for this video. I'll see you next time.